This is the Chapter 10, Section 1 podcast, and it's on cell growth. And we're going to look at the problems that cells encounter when they start to grow. And the problems are twofold. One, it has to do with related to the DNA, is that the larger the cell becomes, the more demands the cell places on the DNA. And the second part is about moving materials. In addition, the cell has more trouble moving enough nutrients and waste across the cell membrane. So the larger a cell becomes, the more demands the cell will place on its DNA. And as your cell size increases, it's not going to make another copy of the DNA. It's just going to keep its one copy. And so if your cell grows without, keeps on growing, eventually you're going to have what's called an information crisis. And the best way to explain this is by using an analogy to a library. If you have a town, and the town starts getting bigger and bigger, and it has one small library, more and more people are going to use that library, and more people are going to want to use the same library books. And when the library books are out of the library, there are people without that information who have to wait to get that information. And a similar thing happens in a cell. As the cell becomes bigger and bigger, there are going to be more parts of the cell demanding access to the DNA. And if the DNA is constantly being used by other parts of the cell, you're going to have the information crisis, where there are parts of the cell waiting to access the information, the DNA. The second problem they have is with moving materials in and out of a cell, and it's the rate at which you move things in and out of the cell is dependent on the surface area. The more surface area, the more places you can move things in and out of the cell. But the rate at which the waste and is produced and resources are used depends on the cell's volume. And the problem is that they don't increase at the same rate. The volume is going to increase faster than the surface area. So you can see that's a problem. There's going to be more waste and materials needed than there will be surface area to support this eventually. So as the surface area to volume ratio gets bigger, surface area to volume ratio gets more disparate, it's going to become more difficult for the cell. And let's look at this. We can approximate the cell as a square. So here's a 1 centimeter by 1 centimeter by 1 centimeter cell, and you can see that its surface area is going to be 6. Its volume is going to be 1, so the ratio is 6 to 1. Whereas if you double the surface, double the dimensions of the cell, making it 2 by 2 by 2, now the surface area is 8, but the volume has now gone up to 24, and now your ratio is 3 to 1. So your volume to surface area ratio gets smaller and smaller, and that then presents the problem for the cell. Now here's a good example here. Here are two cats, and you can see when we talk about surface area to volume ratio, you can see this cat being very small, it has very little volume in it, and this cat has an enormous amount of volume, but its surface area hasn't grown as much as its volume has. So and that's the analogy we're making to the cell. So before a cell becomes too large, what it's going to do is divide into two daughter cells, and you'll hear us use that phrase again and again. This is the cell cycle right here, which we'll look at more closely in the next chapter. And the process where the cell divides is called cell division, and we'll talk about that in the next section.